Every winter, Delhi's air turns hazardous, and the same promise returns. Let's make it rain and wash the pollution away. Cloud seeding sounds like a technological shortcut, but winter smog is not primarily a weather problem. It is an emissions and governance problem, made worse by winter meteorology. Delhi's winter smog forms when calm winds, low temperatures, and a shallow mixing layer trap emissions near the ground. Vehicles, dust, construction, industries, waste burning, and episodic spikes like stubble smoke and fireworks accumulate faster than the atmosphere can disperse them. Under pressure, governments often search for a single visible fix. Cloud seeding becomes attractive because it looks decisive. Cloud seeding is weather modification, not rainmaking from nothing. It introduces tiny particles into existing clouds to encourage droplet or ice crystal growth. There are two common approaches: warm cloud or hygroscopic seeding using salts to help droplets merge into rain, and cold cloud or glaciogenic seeding that promotes ice crystals. Crucial point: seeding can only modify suitable clouds. It cannot create clouds in a dry winter sky. Delhi's peak pollution season, roughly November to January, is typically cold and dry. Suitable moisture-rich clouds are often absent or fleeting. Even when clouds appear, they may lack the depth and updraft structure that seeding needs. That means the probability of seedable conditions is naturally low, especially on the very days when air quality is worst. Winter air below cloud base can be dry, so even if seeding triggers precipitation aloft, it may evaporate on the way down, what meteorologists call virga. That produces little surface rain and minimal washout of particulates. In short, even a technically successful seeding flight may deliver negligible cleaning at ground level. Here's the hard truth. Delhi's pollution is sustained by continuous sources. Studies and institutional assessments often identify transport as a major contributor to Delhi's PM 2.5, commonly cited in a broad range, roughly about 1/5 to 2/5, depending on season and method, alongside dust, construction, industry, and burning. Even if a drizzle temporarily reduces PM levels, emissions keep flowing, and concentrations rebound quickly under the same winter lid. When AQI crosses 400, governance shifts into emergency mode because health risks and disruptions become visible. But smog is seasonal, not a single-day event. A short washout can create false confidence while chemistry keeps rebuilding pollution. Secondary aerosols form from gases like NOx, SO2, VOCs, and ammonia, turning into fine particles that return quickly when dispersion remains poor. To be fair, cloud seeding has defenders. 1. As emergency harm reduction, any temporary drop can reduce acute exposure. 2. It signals responsiveness. 3. It builds scientific capacity. If treated as a controlled experiment with transparent criteria, dense monitoring, and independent evaluation, the risk is turning a conditional tool into a political substitute for emission control. Globally, cloud seeding is used in limited contexts: snowpack enhancement in some mountain regions, rainfall augmentation in select arid zones, but even proponents treat it as probabilistic. Attribution is difficult. You must prove the rain fell because of seeding, not natural variability. That is why serious science frames it as may increase precipitation under suitable conditions, not as guaranteed precipitation on demand. A credible winter strategy must prioritize airshed governance, coordinated action across NCR and neighboring states, strict dust control, construction compliance, cleaner freight and public transport, industrial fuel switching, and bans on open waste burning. Institutionally, action sits within India's environmental governance. Air Act 1981, Environment Protection Act 1986, the CAQM framework for NCR, and emergency measures through GRAP-type responses. Cloud seeding may look like science in the sky, but the real science and the real governance is on the ground, cutting emissions at source and managing the airshed. Rain can buy a few hours. Only structural policy can buy a clean winter.